In Figure 4.2, this is just a nice summation of textures and how texture and cultivation or not cultivation can affect bulk density and pore space. Okay. So you'll discover a little bit more about pore space in section 4.8 when you read about pore space, and we'll cover it some more in a little bit. But right now, what we're doing is we're just looking at 4 different soil. Actually, this is several 6, 7, 8, 9, 10 different soils. Okay, and I'll ask you the question because you need to know this. See this little word right here, eudolts. Eudolts. What soil order is that? What soil order is a Eustalf? Okay, remember, looking at the end of these words here tell us or signal to us what order they are. So remember, ULT will equal ultisol. Okay, ultisol. ALF, that will equal alphysol. Alphysol. Okay. So I'll give you an idea of what soil we're dealing with here. As we move over in this, we can look at the texture, the years cropped, and the cultivated soil. If it's been cultivated, how long? If it hasn't been cultivated, what does that look like? So we're just going to pay attention to this bulk density measurement here, and we can see that with a sandy loam, just like we had mentioned before, a sandy loam, this one right here, has a bulk density of 1.59 when we cultivate it, so that's a fairly high bulk density. Okay, it means it's more compacted, let's say, or more dense per unit volume. For the uncultivated soil, we have a 0.84, which is a lower bulk density. When we move on to a silt loam, okay, silt loam has a 1.18 with cultivation and a 0.78 without cultivation. Okay, so you'll notice that as we said before, generally speaking, it's not 100% of the time, but generally speaking, what happens is that we've got a higher bulk density for our sands than we do typically for our other silts and clays. Okay. Same thing happens down here. So we've got a sandier texture with a little bit higher bulk density, clayey texture with a little bit lower bulk density. When we don't cultivate the soil, we get a lower bulk density. Okay, and this is just informational purposes. I mean, you need to understand that soil cultivation isn't a horrible thing just because it changes the bulk density from one thing to another. Cultivation is a necessity in many cases to produce agricultural products. Okay, but what we don't want to get to is very, very high bulk densities. That's not advantageous because because plant roots can't grow through that sort of density that we might find in those situations. Figure 4.23 on page 119 in your book shows a carrot, for instance, in a fairly dense profile being impeded by how dense that soil is, and so it can be a problem, but it's not always a problem. This gives us a good comparison between bulk densities with cultivation and without cultivation.